Trigonometry, the inverse trigonometric functions arcsine, arccos and arctan. You need to know about the inverse trig functions. These are the inverse functions of sine, cos and tan. And an inverse function can only be drawn for a one-to-one function. When reflected in the line y equals x, a many-to-one function will become a one-to-many and hence not a function at all. So if we look at y equals sine x between minus pi over 2 and pi over 2, then the output is between 1 and minus 1. So in that domain, for minus pi over 2 x to pi over 2, the range, the output values are minus 1 is less than or equal to sine x is less than or equal to 1. When we sketch the inverse function, you can see that we reflect it in the line y equals x, so that's the line y equals arcsine x. And now, for y equals arcsine x, the domain, well, it's the range of sine x, so the domain is minus 1 is less than x is less than 1, and the range is minus pi over 2 is less than arcsine x is less than pi over 2. Now we can't use minus pi over 2 is less than x is less than pi over 2 as the domain for cos, because that would be a many to one. So instead, what we're going to do is have cos with a domain going from 0 to pi, because a domain of 0 to pi for cos x does mean it's a one-to-one function, and the range is minus 1 is less than cos x is less than or equal to 1. Again, we can reflect that in the line y equals x, so it now looks like the blue line. That's the reflection of the red line. That's y equals arccos x, and swapping around the domain and the range gives us that the domain of arccos x is minus 1 is less than x is less than or equal to 1, and the range of arccos x is 0 is less than or equal to arccos x is less than or equal to pi. So that's the trig function arccos x. Finally, for tan, there's the graph y equals tan x. There's a subtle difference here. Because of the asymptotes, it means that the domain is minus pi over 2 is less than x is less than pi over 2. It can't be equal to pi over 2 because it approaches what it never gets to. And the range is any real number, because the range, the graph goes up and down, and because it never gets to pi over 2, the domain is all of the real numbers. When we reflect it, we get that line there, arctan x, and when we swap the domain and the range over, it means that for arctan x, the domain is all of the real numbers, and the range is minus pi over 2 is less than arctan x is less than pi over 2. Again, it has asymptotes. In this case, the asymptotes are y equals pi over 2 and y equals minus pi over 2. There's a summary. There are the three graphs of arcsine, arccos and arctan for the functions. So be aware of what the domain and the range is for each of those functions and the asymptotes for arctan. So we need to be able to use these trig functions in order to work out values. So here's an example. Work out in radians the value of arcsine 0.5. Arcsine 0.5, in terms of calculator buttons, it just means the inverse sine of 0.5. So that's going to be pi over 6. That's one of the ones we should have memorized, should have learnt, or we can push the buttons on a calculator, and those new modern fangled calculators probably will say pi over 6 anyway. That's the same as 30 degrees. Work out in radians the value of arctan root 3. Well, that's the same as inverse tan of root 3. Again, it's one you should know, so it's pi over 3. If we were working in degrees, we'd be saying 60 degrees for that. Work out in radians the value of arcsin minus root 2 over 2. So the arcsin of minus root 2 over 2. Arcsin just means inverse sine. We can ignore the negative for now and the values from earlier, and if we work out inverse sine of root 2 over 2, that equals pi over 4. Sine minus theta is the same as minus the sine of theta. You can think of that also if you imagine the sine graph. Then you could draw a little sketch and you could see to yourself that the sine of minus 30 degrees is the same as minus the sine of 30 degrees. Draw a sketch if you're having trouble imagining that, and you should see it work. So root 2 over 2 is there. That gives us pi over 4. So minus root 2 over 2, using the symmetry of the sine graph, we can see gives us minus pi over 4. So the inverse sine of minus root 2 over 2 is minus pi over 4, or minus 45 degrees if we were working in degrees. Work out in radians the value of cos arcsine minus 1. Cos of arcsine minus 1. Well, arcsine just means inverse sine, so it's the cos of the inverse sine of minus 1. Think about what value you need to get. You need for x to get sine x equals minus 1. If we draw a little sketch of the sine graph, we can see that to get sine x as minus 1, that means that x must be minus pi over 2. So it's cos of minus pi over 2. Cos minus theta is the same as cos theta. Again, think of a sketch of the cos graph. If you think of a sketch of a cos graph and the symmetry of the cos graph, you can see how that works. So cos of minus pi over 2 is the same as cos of pi over 2. And cos of pi over 2 is equal to 0. And you can see from the cos graph that's the same as cos of minus pi over 2. In summary, in the last 3 videos, that's video 18, 19 and 20, if you want to look back at them, we've learned about the 3 new functions based on sine, cos and tan. We've seen lots of new identities we can use in solving equations and proofs. And we've also looked at the inverse functions arcsine, arccos and arctan.